It's related to gravity. So you know about it, right?
Mm-hmm.
Okay. Now see, although I mean, as funny as it sounds, it started off from this apple falling and all of those things. Uh,
Mm-hmm.
but it actually led to a situation in which Newton started to think, what exactly is this? He just observed that there was this tree and there was an apple falling. Okay. That's the only thing that he observed, and it made him think a lot of things around this topic. So today what we are going to talk about is a very, very important law which he had given, and that's why it's called as the Newton's law of gravitation. Okay.
Mm-hmm.
Now, what he did was he kind of associated two of his own laws, and you can say that he brought them together. Which were those two laws? First, I'll tell you that, then we'll go ahead with this topic. So, you remember the second law of Newton?
No.
Okay, no problem. So the second law said, I'll give you an example that if there is a box, let's say, okay, and you apply force to this box, the box will start moving, right? And that's when he gave the second law, which was that force is equal to mass into acceleration of the object which is moving. Okay, that was the second law that he had given. Do you remember the third law of Newton?
No.
Okay, no problem. Uh, okay, so this is related to this line that to every action there's equal and opposite reaction. Now, do you remember?
Yeah.
Okay. So it's like whenever there is an acting force, there is always a reaction force also. So he is going to, hi, who's this? So he is going to use both of these, the second and the third law, and he is going to combine them into this law. Okay, so don't worry about it. Right now, we'll just talk about what this law says and everything. And later we can see if, one second. So what does this law say is that any two objects that are kept uh, at some distance from each other, let's say there is a ball A and there is a ball B. Okay, what does this Newton's law of gravitation say is that at every time there is an attractive force with which they are trying to pull each other towards themselves. Okay, any two objects. For example, even for example, me and the laptop in front of me, these two, we are also two objects in a way. We are also trying to pull each other. Okay, that's what law of gravitation says, that any body, any body which is present on the earth right now, we're talking about earth, exerts a gravitational force on each other. But this does not remain only to the earth. It is like anywhere actually. So for
Mm-hmm.
example, the reason moon is able to go round and round around the sun is also because of this. Okay, so like for example, if this is, let's say, an object of mass m1 and this is another object of mass m2, they both are attracting each other with a force, and this force is called as force of gravity. See, when Newton observed the apple falling down, that is also force of gravity. Okay, so if suppose this is an apple and this is the ground, right? So I can say that this is my Earth. So there is a force of gravity even between the Earth, or you can say the ground, and the apple. That is why as soon as the apple gets detached, because of that force of gravity, it will fall down.
Mhm.
But people can also ask why, like we are saying that they both are pulling each other, right? That means
Mhm.
apple is also pulling Earth.
Yeah.
Then why is it that Earth is not moving towards the apple? Why does it happen that apple falls down, but the Earth will not be able to go towards the apple? Do you know why that happens?
Because the apple has less force of attraction than the
So
earth, so it's neglect.
so it's actually the force of attraction is the same for both of them.
Mm-hmm.
That's that. But no harm there. You were, I mean, giving an answer which was as you think was okay, because right now you don't know. The thing is that both the forces are equal.
Mm-hmm.
Okay, that's the other part. Like for example, the force with which M2 is pulling M1 and the force with which M1 is pulling M2, it's actually equal. These two are equal to each other.
Mm-hmm.
Okay, so actually it's the same force, but still the Earth will not move towards the apple will move towards the Earth. Any
Mm-hmm.
idea why does that happen? Think about it once again. See if you can.
Because the apple is lighter than the
Very
earth.
good. Correct. Absolutely. You're right. It's actually because of that. So you remember inertia.
Mm-hmm.
Inertia, do you remember?
Kinda, yeah.
Kind of. Okay. No problem. That is okay. That much is okay. Kind of is also okay for me. So, like you said, the object that is heavier, you will always require more force to move it, right?
Mm-hmm.
For example, just imagine this situation that, let's say there was an object which was small object and the mass was only 1 kg. But there is a bigger object for which the mass is, let's say, 100 kgs.
Mm-hmm.
If I apply the same amount of force to both of them, this one will move very quickly, right? This one will take a lot of time to move. That's exactly what happens with the apple and the Earth. Because the apple is lighter, much, much lighter, in fact, in comparison to the Earth. Even
Mm-hmm.
with little bit of that force, it will fall down. But the Earth is so heavy that even if you're applying, like for example, the wall, even if you're applying force on the wall, it does not move, right?
Mm-hmm.
Because it's very, very heavy. It's similar thing with Earth also, and that's the reason the Earth does not move towards the apple. It's the apple that falls down, but
Mm-hmm.
force is actually acting on both of them. See, until your ninth standard you knew that there is a force of gravity because of which the apple falls down and everything. But what happens in class 11th is that you will understand that this force is not only acting on the apple, it's also acting on the Earth. Okay,
Mm-hmm.
so that is what this force of gravity, or you can say the Newton's law of gravitation, means. That any two objects are always trying to attract each other.
Mm-hmm.
Okay, but they will not move. Why will they not move? That also we will understand. Now, see, now you've understood that there is a force of gravity.
Mm-hmm.
And the formula for that force of gravity is this. But I'll tell you what does that mean first. So this force of gravity, what does it depend upon? So let's say that this is an object of which the mass is capital M, and this is another object